Okay, can. Maybe it's mine. Let me check. Yeah, so later we'll just show briefly on the multi-tenancy point of view from Loki stack in within OpenShift, right? Just a few things. I think now logging is 5.7, previously it was 5.6. Not much changes, right? Just that we are now allowing we are now having tech preview for Tempo, right? Which that's why we invited Grafana today to speak more about it as well. Um, yep, just things like tech preview, Tempo, trace virtualization using Jaeger UI. Hopefully later you can see Tempo in action. So maybe just a brief view, right? From a logs point of view, I have a cluster here up and running. So for the get-go, I have, for example, this new feature here called logs, where I can view, for example, infrastructure logs. And this is the same kind of QL that typically you will see in like Grafana and so forth, right? Which you can run the query from here. So this infrastructure logs itself, right? You can of course do things like filter by namespaces, by ports, containers, so on and so forth, right? So there's a few ways to look at which particular log you're trying uh, to add. You can go to a developer view, right? Developer view, from a developer point of view, we want to be able to allow multi-tenancy within the project itself. What does that mean, right? For example, today, if I were to create a sample application, was a Node.js, or maybe I should do this first. Create a new project. Right? Just create a sample. Okay. So in the observe tab itself, right now I have these logs where I can filter by ports, by containers, right? Let me see whether things comes up. Right, you can see here, right now it's pulling. So from a developer point of view, you're able to see those logs out of the get-go already, right? Previously, you might need to probably go to another user interface, and then you might need to give access to a developer to that user interface itself. The process might be a bit more tricky, right, for a developer to view logs at the start, right? So this allows you to have multi-tenancy between projects, right? Allow the developer to straight away look at the logs. So I filter by ports, I can look at the build, so on and so forth. So I guess this is just an overview of what Loki stack is within OpenShift itself, right? So maybe I take a pause here for any questions. Okay, I think quite straightforward. So I think that's mostly what I wanted to show. There isn't, I think, much new features for this particular release to 5.7, right? So maybe I'll pass my time to Alfredo.
This one is only for OpenShift 4.13 or
4.12, you can really use Loki stack. 4.13 onwards, you're able to have Tempo as a tech preview.
So the Kibana is totally removed.
So now OpenShift default stack is moving towards Loki. You still can use the EFK stack. Yeah, as of today, you still can use it.
So, hi everyone. My name is Alfredo. So I'm part of the solution engineering team here in Grafana Labs. So you can see from the chats, not from the Red Hat team. So thanks so much for their invite for today. So they kindly has invited me to share a bit more about Grafana Loki and Grafana Tempo for today. Which is, if you look about the Grafana itself today, many people, I guess, like I've been in Grafana Labs for a year now. But when I was meeting many our customers, users, when I'm asking them, do you know about Grafana? Everybody will say yes. But then they will say like, all right, you guys are the guy that do the dashboard. There's kind of like things that you can do with dashboards, right? But the fact is Grafana has kind of changed a lot since then. So it's true that Grafana, we started back then as the visualization, the dashboarding part. That's the main core, still the top layer part, the visualization that you see. That's one unique thing about Grafana is that you are able to use this plugin ecosystem within the Grafana itself for you to connect with other data source wherever you have your data. So if you are having data, say like in Elasticsearch, or you have data sets in Prometheus, or you have data in like InfluxDB or any of like ServiceNow included and many other things, you're able to use the plugin and essentially pull the data from there and present that to you within the dashboard itself. So this kind of solve one biggest problem we have when there are so many teams having their own tools. The problem comes from how do we achieve that end-to-end view, while still we do not want to enforce them to change the tools that they've been comfortable with. So Grafana allow that capability. And of course, with Grafana, it's not just dashboarding, you're able to do like alerting as well based on these data sources that you have set up. Now from there onwards, there are multiple projects we built on because Grafana has been kind of like very closely tied with Prometheus, like the whole Kubernetes, Prometheus, and Grafana kind of like it's been back to kind of like married to each other now. So Grafana closest project next after this visualization is something around the metrics. So this is the area where we have something back then is called the Cortex project. But then now we have changed it to something called Mimir, which essentially it is a drop-in replacement for Prometheus backend. So whatever you do with Prometheus is still the same. It's just that for the backend storage itself, you use the Mimir itself. So your exporters, your agent, all of this pretty much will work together. Just Mimir will work better handling all those like long-term durable storage, query, better query, and all this kind of thing. You're still using PromQL for that as well. The other project we started off as well is, of course, on the logs. We call that Grafana Loki, and which is what I'm going to cover in depth today. And we also have the area for tracing called Grafana Tempo. We also will cover that today. Other than this, we also have some other kind of like pillar around the performance testing, the shift left whole kind of conversations. This itself is not something we built. It's actually something that we acquired from a company called K6. If you guys been using K6, then pretty much now it's under a Grafana Labs. And we also provide K6 now under the Grafana Cloud solution as well. And the next part, things like we are kind of like heavily building on and it's been a lot of improvement is on the incident response and management side. This is where the area we build on like things like on-call, incidents, and we are also going to build something around the SLO management included as well, right? Now, as with Grafana, many of the products here, pretty much almost all, they started off as open source. The same goes for Loki and the Tempo as well, which I'm going to talk about as well today, right? So one thing that's interesting is when I sort of like first thing look at the company, they're always talking about this LGTM stack. So that's pretty much what we call our Grafana solutions when we talk about the area of like the observability side, right? We call it LGTM stack. So LGTM, L stands for logs, which is the Loki, and then the G stands for Grafana, and the T is the Tempo for the tracing, and the M stands for Mimir, right? Which I find it's interesting because if we kind of like talking about LGTM, this is a term that almost everybody, developers, they all like knows about that, right? Which is just when I kind of look back like the history behind on the naming, I started to questions like, are this engineer kind of have this idea long back when they started with the whole naming of Mimir, Loki, and Tempo, which is never got the answer yet, but that's where we are with the LGTM stack. Whether if there's some stickers outside as well, if you kind of want to pick it up, the whole LGTM stack stickers are there. And there's one Grodd stickers as well. The guy with the sunglasses, I think sunglasses. Yeah, it's kind of like our mascot. So I think everybody understand why logs are important. Just now, I can show a lot of things about like what we can see inside the log as well. There's multiple use cases for the developers, for the monitoring team. So even for like the SRE, anybody have the use case for that, right? But then one thing that kind of like people sometimes get confused with regards to, we talk about logs and sometimes we talk about metrics. Are they the same or they're actually two different things? Simply put, they are a little bit different. So if you talk about logs, we're just talking about kind of like chronicle orders of events. So if there's a kind of like text that we are looking at this timestamp, something happened, there's a GET request, follow with whatever going on, there's an error and so on, right? With metrics, everything is related more about the numbers. Everything is about numerical numbers. So if you think about metrics related to the CPU usage, so we have just the numbers that belongs to that metric name, say Linux CPU usage, for example. So these are two primary different. We talk about logs and metrics that tends to be different. Later on, we also talk about you can actually convert your logs to be a metric. So it doesn't mean that you look at your logs, it's just the plain text. Doesn't mean you are not able to get some metrics out of it. You are able to do that later with like LogQL that I'm going to show you as well. So when we started with the whole Loki project, we are trying to think of a way to solve these three challenges, right? Because we talk about logging solutions, there are a fair bit of logging solutions out there. One of the things that we want to solve is that some logging solutions are difficult to operate at scale. So we're talking about ingesting like petabytes of data a day, terabytes and stuff like that, right? And then even though it's able to scale, sometimes the problem comes on, it becomes extremely expensive to scale. Not just from the infrastructure cost, talking about like the storage, it requires a lot more storage. And sometimes also comes from the perspective of the complexity. So there's also a cost that is kind of like indirect cost to the users, the team who is actually managing the resources, the effort they need to put in. And lastly, some logs tend to be like standalone by themselves, and it's difficult to correlate like things with metrics. And then lastly, the whole observability, the third pillar is around the tracing, and something new coming out is like this profiling as well, right? So these are the three challenges that we try to solve with Loki. And we make Loki primarily to address this in the area like for the DevOps people, for them to help like perform a debugging, troubleshooting of the applications. And of course, for the SRE, help to visualize if there's any alerts happening in their service applications based on like maybe impact to performance. And of course, also able to help like the data engineer if they want to build some insight out of their logs or any other data source, right? So Loki itself, it's built to be efficient at scale, built for correlations. It's format agnostic, and you can generate metrics out of your log. So you're not just looking at the plain text itself, the log lines. You're able to generate some metrics out of that as well. So a little bit of history about Loki itself. So as of today, it's versions 2.8. So that's June 23. But the whole Loki project at first was started like back in 2018. And the first beta release was like in 2019. And it's been just for the short like 3-4 years, and we have received a lot of star in GitHub already. So the last we see here, like just June this year, we have like 19,000 over star, which is kind of like growing. I believe it's like the second, or if not the third. I think it's the second largest project of Grafana that we have, right? Comparing like things. Of course, Grafana been around itself been a lot longer. So there's like number one, and then we have a Loki just behind them. So when we talk about Loki's format agnostic, Loki pretty much able to accept logs in any kind of format. So it's not necessarily like it's in structure or unstructured. We can able to ingest that. It can come from like things from your applications, your infrastructure services, your Linux logs, your Windows log, IIS, Kubernetes log, or Docker log as well, right? All of this pretty much can be ingested into Loki. And you'll also be able to pretty much, if you want to, you can actually push log directly to the Loki endpoints if you want to, right? Now, what happened is Loki itself, we create a kind of an agent that allow you to forward this. This is what we call as Promptio, right? Don't ask me why the name is like that. I've also been questioning myself. But Promptail pretty much is the agents that you can use to tail your logs and then push it out to the Loki itself. And Loki itself work with object storage to store the index and the chunk. That's pretty much one of the reasons why Loki is much cheaper when you want to scale that, because with the object storage stuff has been evolving a lot, and then the level of compression and the cost cooperated with it is pretty much lower compared to other traditional local disk, for instance, spinning disk or SSD, right? Now, when you are accessing Loki, there are two ways actually. The first way is if you just want to quickly look at your logs, you can actually run the log CLI, which is a command line interface that you can run the logql direct, which is the Loki query language, against the data, and you can get the results. Another option that is more common is using Grafana to connect with your Loki data source, and you can build the query from there, and then of course you can build the dashboard as well. Okay. Now, Loki doesn't just mean it works with Promptail. It also works with Grafana itself. We built an agents data pipelining solution called Grafana Agents. Grafana Agent has an embedded Promptail in it. Other than that, Grafana Agent goal is to be this one single agent to collect your metrics log and the traces. So we also have the Prometheus agents embedded in it. So it's not the full Prometheus, it's just Prometheus scraped down to the minimum to be able to just do the job of scraping the metrics and pushing it out. And lastly, for the tracing, we're actually basing it based off OpenTelemetry collectors, right? Loki itself also able to receive data from things like Lambda, Fluentd, or even directly from like maybe like Logstash, for example, here. Now, what are the options when you're installing Loki? So if you go to our documentations, there are multiple ways you can do that. But simply put, these are the three common options for you to deploy Loki. If you are doing like testing, just a very small environment, just in your test lab, for example, like your in your own desktop, for example, you can deploy Loki in like a single binary. So this is what we sometimes refer to as the monolithic style of deployment. Every Loki component is just installed as one single service. Loki itself is really built more as a cloud native in mind. So you can see a lot of the components supporting that, but with single binary, we just package everything into one. The second option is called as the simple scalable deployment, SSD, we call that. Honestly, it's just pretty hard to remember. I just like to think about that. We use simple scalable deployment by just separating the read and the write path. So the services is just two, the read and the write path. Now within the read and the write path, there's a few other components actually that we'll be talking on a bit. That if you are going with a microservices, which is actually the most advanced and also complex, also the most efficient, this will be something that you are exposing as individual services. So we have the single binary at the most left side here, and then we have something that is kind of like in between before we go to the microservices mode. What we recommend is for people to start off with a simple scalable deployment if you're doing like a productions, because we have tested that it's able to scale for like terabytes of data already. And it helps in terms of management as well, because it's not as complex compared to the microservices. Microservices is super powerful. It's the strongest, I would say the most powerful type of deployment, applicable to Loki, our Mimir project, and also our Tempo project. But the problem with microservices is it's a challenge for you to understand which knob you want to fine tune. Microservices pretty much have like 100 different knobs presented in front of you. Do you understand which one you want to kind of fine tune? So it becomes a bit complex in that sense. So unless it's really required that you go for microservices, we usually recommend to go with a simple scalable deployment because it's able to address most of the use cases already, and it's much simpler from the perspective of the setup.
Like some of the start the demo from Derek, right? Yeah. That one is SSD method, is it?
I'm not 100% sure like what the OpenShift developer did, but it might be more on the microservices side. But everything has been handled.
Yes. So what Derek showed is install it actually through an operator.
Yeah.
Yeah, so it's very likely through the microservices.
Oh, yeah.
Yep. But then with the whole OpenShift, when I look at it earlier for the first time, it's a lot of there's a, like abstraction layer that's been handled already for you guys, which is nice. So with Grafana Labs ourselves, we have services that run as our SaaS. So we have Grafana Cloud and we host Loki there as well. We run that in microservices mode. So we can, because we are handling multiple customers, multiple data types as well. In a simple view of like the read and write path, I'll just use this as an example. So for pretty much all the metrics log and the traces project that we have, we use kind of like similar style of architecture, which is most of them pretty much coming from the Cortex beforehand. So we have things like the distributor, ingester, we have the query front end and the query itself, right? Simply put, for the simple scalable deployments, we have two more, which is like the write path and the read path. For the write path is where things like the distributor, ingester will be part of. And for the read path, that's where the query front end and the query will comes in, right? So this is the area as well. Some of the things will happen. I will not go through in detail what each of them are doing. But if you go through our documentation under the components, you can sort of like read through to understand what is distributor responsible for, what is ingester responsible for. Some of them pretty much a straightforward. Ingester job, of course, to flush the data into the disk. Distributor job is kind of like the first person who will receive the incoming logs and distribute that into ingester based on the replicas that you have as well. And the same goes for the query front end and the query. Okay. Now for the Loki distribution itself, as I mentioned about earlier, of course, it's an open source. There's also an enterprise version that is we offer from the Grafana Labs, and lastly we have the hot version as well as part of the Grafana Cloud offering itself, right? With the Grafana Cloud itself, we also have like the free version that includes some of the usage from there. Now, understanding the Loki model. So this is the part that kind of like going into like when you are accessing the logs, what a couple of things you need to understand. By the way, here, anyone kind of like playing with Prometheus have some idea around it? No hands, man. No. Okay. So Loki itself was heavily inspired by Prometheus. So a lot of the kind of like the log model itself and the log query language itself is pretty similar to Prometheus. So for these examples, we have the Prometheus model. So this like for metrics, we have the timestamp, we have the metric name, we have the label selectors that tends to be in key value pair, and we have the value, which is the representation of the metrics. And this is the format of Loki. So we have the timestamp, and then we have the same label selector, same style that you will have this in the curly bracket, and then you have the content of the log line. Okay. Now in Loki, why we are able to store your log in just like requiring very little amount of storage is because our index size is extremely small. So if you look at here, this is your content of your log line, which tends to be the largest one, right? That's like the full line that you are looking at. All these content lines are actually not indexed at all. We are just taking it, compress that, and throw that to object storage. So it doesn't mean we'll be losing the raw logs itself. Like people tend to refer to this as raw log. It's still there. I just now that I show you that we're still able to query that, but it's just that we don't build index out of these content log lines. Because this kind of like helps in multiple things. Of course, number one, that we can shrink down the index size. And number two as well, you don't need to worry about this process people call as parsing at the index time. So many log aggregation tools, before you even talk about searching your logs, you need to think about how do I parse my log before I index that. Parsing logs essentially thinking about if I have a log line of get, this get should be what field, and then the slash about what field, and so on, right? So this whole normalizations, we'll call it normalizations, parsing. My previous job also is like from a logging company, they call it different things. Essentially, is applying a schema into your file, your log file before actually ingesting it, right? So Loki, we don't do that. And we are able to search this data later on and also apply the schema. So our schema applications doesn't happen at ingest time, but instead it happens at the read time, if that makes more sense. Okay. Now what we keep in the index size are just the timestamp and this label selector. So label selector essentially identify your log line itself. So I should have some examples. Yeah. So this much allows us to keep the index size to be very small. So for examples here, we have 10 terabyte of logs. Our index size is just like around 200 megabytes. So simply put, some people like to think about this Loki style of index as like table of contents. So if you open like very like say Harry Potter's chapter 5, so the thickest of the whole 7 books, you just look at the table of contents, you have like chapter 1, chapter 2, and then the subchapter, all of that. Those are what we actually indexing. So The representation of labels will be what we are going to cover next, which is the log string. So if we have a look at here, let's ignore whatever on the left-hand side here, the timestamp and this curly bracket thing inside. We have the log messages, right? Now, all of these log messages, you can apply some sort of tagging. I like to think about it more like a tagging. This is where the label key value pair will come in. So you can be saying that if I'm collecting these logs from my production environment, I want to tag that as environment equals to productions. If it's development, I want to tag that as environment equals to development. And this one coming from Nginx application, so I just tag that as application equals to Nginx. So what happens here is Loki will group all the incoming logs from the same labels under one log stream. So this is called under one log stream. This is the second log stream. That makes sense, right? Now, when we have this information, that the log stream informations, the rest of the log pretty much will be stored in what we call as chunks. So these chunks entries are pretty much will be stored. We only keep the earliest and the latest timestamp. We'll keep that, and then everything will store inside this particular chunk, and then get flushed to the disk in these examples, right? So when we do the query, we're actually telling Loki first which log stream I want to take, and then from there, based on the timestamp, you will pick up which chunks to open up, which one I can just skip. So the way I like to think about this whole log stream tagging is, you can imagine that you have multiple types of buckets as you want to organize your things. In each bucket, you kind of like put a labels and say that, all right, this blue buckets is for everything maybe related to the paperwork, for example, everything that is papers, I just put in here. I have a second compartment that maybe says that this is belong to anything that is like round shape, for examples, right? So as I'm soldering my stuff here, I'm putting the logs and my stuff into the buckets that I just defined based on the labels. When I want to look back at my contents, I will just choose and say, okay, I want to pick up anything that is from the paper buckets, the paper compartments, and I will do the search from there, just pick up all the stuff. If that makes sense, or like all the whole log stream and labeling as well. So there will be good and bad labels out there, because essentially labels will define your log stream. So if you have like a very high cardinality labels, you will have a lot of log stream, and this will have an impact into the overall performance. So in these examples, anything that is out of your control, in a sense that you do not know how many unique value for a given field, it's better not to use that as a label. So things like the trace ID, user ID, path, status code is arguably, you can use that because it's predefined in the 400, 401, and those kind of things. And of course, date, latency, this kind of thing are the number that has almost can be considered as there's no boundary when this will end. A good labels are those that is pretty static. So you know that like your cluster, you only have like cluster A, cluster B, cluster C, for example. Your namespace, your job, the app name, instance, or the host name, and then the file name. Okay. Now, looking at this, searching the log, which is the logql here, I will actually just use the demo instead, so it's much quicker. Okay, let's run through this one, so it's easier. Okay. So in these examples, I have this raw log. So as I'm running the search, like just now you see, the raw logs itself are all here. So if I kind of like look at the examples here, if I just export that, I think you guys can still hear me, right? So let me just open this one, open this in Explore so we can see how that looks like. So as running the search, I just do a selector of a namespace. Okay. I just do a selector of namespace equal to production, and pretty much I will have all my logs here, right? So there is like kind of like we can consider that as a raw logs. As I'm looking at the raw logs, I have like this considered as a field, but technically these are the labels because we didn't define any kind of fields yet to Loki. Loki doesn't know what is a field. It's just like put up. I understand this log line has all these labels, and then Grafana just take it as a fields. The next thing here, let's say that I want to find a specific logs. when I'm finding a specific logs here, I can just do the log stream selector. So this is like one thing as you are starting your log query, logql, you need to start with that curly bracket to define telling Loki what stream I need to pull first. And from there, let's say that I want to filter for specific expressions. I can just use this pipe follow with equal sign, say null value. So what will happen is it will pull every log line that has a null value. So basically what happens is we know which log stream you want. We just run a brute force a search and capture anything that match the criteria there. Of course, here you can define it equal sign, not equals to, or regular expression as well. It's like it's been kind of like I explained it here. Okay. Now, similarly as well, let's say that I want to search for specific labels, because at this stage, there's still no parsing happen yet. I can also do that by defining the label name, follow with whatever the value I want. Okay. Now, the next thing is where the log parser come to the picture. So if I'm looking at this sample of my log line, I will have multiple things, right? So I'll just show you another one here, make it easier. So let's all look at the Nginx logs. So I want to look at any log line that has a file name equals to JSON access log, and this is log line for all the Nginx, right? You can see all the JSON file, and you can see that there's just a couple of things. But if you look at the JSON, if I choose the Prettyfy JSON here, there's quite a lot of fields there that's quite interesting for me to look. Now, from here, what I can do is I can add a JSON parser. So this is just a UI within the Grafana that have this builder to give you a hint. But if you look at the bottom here, this is actually the logql equivalent. So adding a JSON parser, what will happen is now if I look at my logs, I have more fields. So this JSON parser is the schema application that I was talking about earlier. So schema application will happen at the read time. We have a couple of parser built in, things like JSON, log formatter. Log formatter just refers to if your log line style is a key value pair, like there's a field name equals to whatever the value is. So that's log formatter. We also support tools that is more flexible, things like regular expression and pattern based. Now from here, anything I do from this onwards, I can deal with the field. So for example, if I want to look at this particular IP address, I can do that and it will just automatically add the remote address equals to whatever the sign. While before, without this JSON, the field will not be understandable. So if I do this, I can get the results. But if let's say that I remove a JSON, I run the field, I didn't get anything. Because Loki is saying, what is this remote underscore address? I don't recognize any of it. It's not in the label at all, right? But after I add the parser, which is the schema application, which is a JSON, now I'm able to deal with this log. So this is how, while we don't index the log line itself, we're able to apply the schema at the search time. So this happens as we kind of like get the data out, and then we apply the schema before we present that to you. Now from here, a couple of things you can do. For instance, that I want to do an operations, like we look at the log line here, but sometimes I'm interested to know, all right, based on all this access law, what is the error rate, for examples, right? I can do that by doing, for example, do like a count over time, and then I want to just run that. Okay, nothing perfect in live demo as usual, so give me 1 second. This guy in, shooting something back, all right. And then I will just use the build to add a count over time. This, run the query. So I just did a little bit of change to my query. what happens here is if you look at the log line, so I'll just use this so it's much easier. So at first we're looking at the label filters. This will be translated to this file name equals to whatever it is. And then we follow with the JSON, which is this guy. And then that's where the JSON comes in, right? Now, because I want to kind of like look at my status code by the like my total request by the status code, I can do that by applying the sum by, but before that, of course, I need to add the rate. All this rate and sum by are pretty much similar to the PromQL stuff, right? So what happened is anything you see at the front here will be added as part of this log query language itself. So at first it will do the rate, and then it will sum that by the status. So status here is recognized by Locky because we have applied the JSON parsers earlier. Right? So this is if you under Locky query language, we call this as a matrix query. So we have the Locky query, the LogQL to just search the logs as usual, but we can also use this to search the create metrics out of the given logs, for instance, like something like this. If I want to look at the logs at the bottom, I can just still see that from here. So what from here I can do is I can add that to dashboard in the scenario of Grafana, and I can build some dashboard, for example, something that looks like this. So this is based on all the Nginx logs that we see earlier. We just can see the request count, request per HTTP status code, and we can also see things like the log line as we see fit here. So if you see that the log line here are a little bit different than actual log line. In the Locky, we support something called as a line format. So the way line format works essentially is if I show you my export earlier. So in this, it is also kind of like there's similar applications of this in the explore page. It's a way to convert your log line presented to you here. So this is kind of the full log line. In Grafana, we support something to kind of like say, I just want to show this particular field, for example. This pretty much will change all the log line presented to me. But I can do that in the LogQL as well by just applying that line format earlier. So it's a use case mostly used for like if you are presenting it in the dashboard, instead of reading that whole long line that kind of like people need to understand what's the information I need to capture. Converting it in a line format, something that is more readable for the user, it's helpful. So yeah, so there's just a couple of things you can do with the LogQL, creating the query and then generating some of the log line itself as you see fit. The filter, just now we talked about the filtering as well, like how you can do the filter as you want to go through with that. And of course, last one, just now we talked about the metrics query itself. Right? Questions? Okay. This is the moment that the browser, okay, I thought the Chrome.
But this one, when you want to point to the S3, right, is it done through the Grafana?
So the Locky will store the chunks into an object storage, but as a Grafana querying, so Grafana will kind of like interact with Locky itself. Grafana doesn't even know there's an object storage. You just see that I have in Grafana, we call it as a data source, which to me kind of like get a little bit confusing sometimes. Because in the world of like collecting logs, there's also definition of data source. It's referring to your Windows, your Linux, or whatever infrastructure, right? But definition of data source in Grafana is essentially where your data live. It's where it's kind of like gets stored. So in Locky example, the logs are stored in Locky. So you in Grafana recognizes there's this data source called Locky, and it's just kind of like run an API call whenever you want to query the data. So this is just kind of like examples how the search works. So we have like the raw log size itself. The first thing, like mentioned, when we want to do a search, we need to do a label selector, telling Locky which stream I want to put. Doesn't mean you need to have like the full stream. It's like just roughly like example, just now we have namespace equal to productions, app equals to Nginx, something like that. And then the next thing after you do a label selector, it just kind of like shrink down the log that you need to fetch, that Locky need to fetch. Of course, when you are running your logs, there's always a time. So as you're defining a time frame, like you're still looking for the last 1 hour, last 5 minutes, or certain date to certain date, certain time to certain time. It's again shrink down the log that need to be fetched from the object storage. So we're talking about Locky when it's deciding where should I fetch the logs, right? And the rest of it, we just kind of like use the parallelization and brute force to search the object storage and pull out. So after we recognize which chunk we want to pull, we'll the rest just pull it out from a normal search. Okay, so we talk about the demo. Now, people will often ask, will there be a trade-off? Of course, there's a trade-off in everything. Right? So in Loki itself, if we think about like what Loki emphasizes more is on putting your resources at the query time as you are searching your data. So as you are kind of like indexing the data, it's almost seamless because you don't need to perform all these schema applications, right? And of course, because the smaller indexes, it tends to be cheaper to run as well. And the query is still fast enough for you to search, like we see just now earlier. And you can still kind of slice your log as you see fit in dynamic ways. In comparison, follows that those content indexing style means you are applying schema at the ingest time. Your indexes tends to be much larger. We are talking like sometimes the index can be like double, triple, even 5 times the actual log size itself. So if you have like 10 terabyte of logs, we're talking about you need to provision a hard disk, a storage for like 50, 30, or even sometimes it's bigger, but sometimes can be much larger as compared to original log size itself. And because of that, it tends to be more expensive to run because of the storage. But of course, in terms of like query speed, they tend to be faster because in like Loki, we apply the schema at the search time. So there's kind of like additional step we need to do before we present the data to you. But to them, they already recognize that they're able to kind of like return the data immediately. It's like kind of like a comparison of instead of taking 3 steps, they're taking only 2 steps, for examples, right? But as we see just now, and from our testing as well so far, the query is still fast enough to address the use cases you are talking about when you are doing a debugging, when you're building like a dashboard, for example, building an alerts. So to us, that is the fair enough trade-off to in return to what we get for the pros, right? Okay, so I'm just looking at the time. So it's rightfully we have 6 minutes.
Okay, no worries.
Yeah. Okay. Oh yeah, I can cover 10.2 minutes.
As much as you can.
Okay, so the next part that I'm supposed to cover, because I talk too much as usual, is for Tempo. So Tempo is rightfully is one of our newer project, but if you look like history, Mimir is the newer one because we kind of like take the Cortex and then take it out and then change it to Mimir. But rightfully, if you talk about from the history, metrics has been something we've been working from beginning, and then logs, and then we have tracing now, which is a Tempo. So talking about tracing, this is usually in the area of applications monitoring, application insights, whatever people call that, but it's usually related to the application side. The whole tracing comes to the pictures is because of the new modern architectures of these whole microservices become very complex. So we are no longer talking about the traditional 3-tiered architectures. There's a lot of like one small service calling another service, and then they will bounce back to another service, and just like building all this service mesh like, right? And understanding where the problem comes from, which particular call is causing an issue, which error comings, when there's customer kind of like complaining your application is cannot be accessed, it becomes difficult. And we can look at metrics and we can look at the logs, but it tends to just give you probably like half or 70% of the story, because metrics will tell you what is the request rate, what is the CPU consumption, what is the memory consumption. Logs will tell you if there is an error, but it doesn't really specifically tell you which component caused the error, right? So that's where the traces comes in. It gives you a kind of like full pictures. If you have a service and it does a request, this request pretty much will kind of like bounce to another service before calling another service, and then maybe within that service is calling another one. So representation of service, usually in representation of the request in traces, usually like to be presented in this way. So you have the call itself on the left side, and then we have like this flame graph view. The candlestick here pretty much represent the durations. And here you will have the name of the call, and then kind of like have this tree-like view. And then within each of the component itself, we'll have this detail around the attributes. Now, each of these components is what is called as a span. So trace as a whole, if you look at this, if this is a representation of one request to your, like say your online service, this is what we call as a full one trace, right? Individually, each of this is what is called as a span. So you can see that each of these components are what the span is. That's pretty much what. There's a lot of words here, but that's pretty much where I'm going to. And then we have this something called as a tags. It is similar to what's called as attributes as well. Something that you can think of as the metadata that you attach to your span. So this can be things about like what is the HTTP method, what is the HTTP URL, for example. So all these kind of things that you can attach as part of the instrumentations. Another thing with spans as well, some people when they think about this, then they'll be like, but I have one big service that call another application service and so on. Am I able to, does distributed tracing able to recognize that these are all part of one single request? The answer is yes. That's where the context propagation comes in. Context propagation is essentially thinking about like you have anything happen in like this service A, and before you go to service B, you kind of like leaving some sort of like a breadcrumbs behind that says that, hey, this call are actually part of this trace ID. So as all of these spans comes into like Tempo recognize that everything is part of the one trace and able to build this preview for you. Okay. The question next would be how then we get started with tracing. So tracing itself is required multiple steps, and in most cases also this means talking with your developers and get some of their help. Right. So when we talk about tracing, the first thing we need to do is to perform an instrumentations. Instrumentations done, and then we do the collections before we store that, and later on we visualize that. So let's talk about instrumentations. Instrumentation essentially is a process that happens at your applications level. By default, your application doesn't produce any form of traces at all. Another way is like Prometheus as well. Sometimes there's a concept of exporter. So it's a way to kind of expose the metrics. So I like to think about it similar to that. So with the traces, it's essentially instrumentation helps to generate the traces informations out of your applications. So there are two ways to generate these instrumentations. If you're talking about OpenTelemetry, there's quite a couple of ways to do instrumentations nowadays. We have things like OpenSensors, Zipkin, Jaeger, and OpenTelemetry has been picking up quite a little bit recently. OpenTelemetry has support two ways, the manual instrumentations and also the auto instrumentations. Manual instrumentation gives you all the knobs that you want. You can control whatever you want with manual instrumentations, but the cons is it requires you to change your application's code. So it's an approach that is intrusive to the applications directly, right? But in return, it gives you all the flexibility you want, all the control that you want. Second one, with automatic instrumentation is much easier because it's less intrusive. In most auto instrumentations, what will happen is at your application's runtime, we just add the OpenTelemetry SDK, say like Java, before you're running it, we just define the OpenTelemetry SDK into that as well for the auto instrumentations, and it will automatically generate the traces for you. Okay, but of course, comparing with manual instrumentations, there is lesser flexibility in terms of like what kind of information you want to see. Once you have the application generate the traces that you want, then the next thing is collecting it, because it's just now we have these applications that just keep emitting the traces. Now we need somebody to pick it up and store it somewhere. Picking it up, this is where the collecting part comes in. You can think of it like setting up your tracing pipeline. When you are setting up your tracing pipeline, there are multiple ways you can do that, like OpenTelemetry, as they are exposing the traces. You will set up like OpenTelemetry collector, where this is the place where it will collect and receive the spans before sending it to the actual storage system, the backend storage. In Grafana, we have like this Grafana agent just now earlier I was talking about. We have embedding the OpenTelemetry collector as part of the tracing collection as well. There are multiple benefits with this, having this kind of like middleman as a collector. It helps you to buffer the spans, ability for you to apply some sort of like aggregations you want to. You can do like sampling instead of getting all the 100% of the spent informations. I said that I just want to take a few percentage of that. You can do that as well. And for some of the stuff, you're able to generate some more things like ad hoc metrics and so on, right? Now, as you are setting up your tracing backend, this is the place where the trace will be stored. There are multiple tools out there that does these things like Jaegers, and of course, we also have from Grafana the Tempo. Grafana Tempo itself, if you look at this so far, is a backend storage system for traces. So there is no term something called as a Tempo tracing protocol. There's no such thing, because we are just using, we are just accepting what ever OpenTelemetry support. And also we also actually support Jaeger trace format as well. So we support things like Open Sensors, Zipkin. We support some of this open standard tracing to store it in our backend. So Tempo is more of a backend storage system, and we work with all this open standard tracing format. So Tempo itself has been designed to be, like I mentioned, easy to deploy and scale in the Kubernetes infrastructure microservices style. It pretty much has the similar architecture as like Loki and the Mimir earlier. It has index free, so it's cost effective. So storage stuff is pretty much cheap, and it can be integrated with Grafana, Prometheus, and of course Loki. It is OpenTelemetry native and also support other compatible tracing like Jaegers and a few others here, right? So this is a simple architecture of Tempo. If you look at it, it's pretty much, in a way, at a glance, you don't even know it's a Tempo. You think it's a Loki because it's the same. You have the distributor, we have the injector, we have the query front end, and we have the querier. One thing that Tempo has here is something called as a metric generator. So this is the part that I'll just talk a little bit while we're on these slides. So as the traces comes in, just now we see all the information, that flame graph. It tells us quite a lot of things. One thing that this metrics generator does is look at the spans, informations, and generate additional metrics. These additional metrics can be things like the request rates, error rate, if there's any kind of failure or not in your span. That helps you to make your applications inside dashboard, for example, or kind of like monitor your application as a whole. Right? So to give you an example here, okay. So here I have this dashboard, right? Typical Grafana dashboard. Of course, I use like theme, the dark theme. I have here the request rate. I have the error percentage. I also have the latency. If you look at all of this, these are all pretty much is a metrics. It's not traces. But all of these metrics is generated out of the metrics. The metrics are generated out of the traces that I receive. So as Tempo receive these traces, it generates information like the request rate, the error rate, and the latency informations as well. So you're able to do things like build this dashboard for your, say, your applications team, or for you to kind of like understand more about what are the things that's going on as part of your all this request line, right? Now from here, I kind of like look at, all right, there's a few error in my payment. I can go into clicking into that. This will bring me to the explore page, and this is like a good segue for me to explain to you how you interact with your traces. One way for you to interact with your traces, you can just like do this like drop-down search stuff. Recently, we announced something called as a trace QL. So trace QL is available in the recent release of Tempo earlier a few months back. It's essentially a query language that allows you to tell Tempo which spans you are interested on. So in these examples, I basically telling Tempo, give me all the span that has an HTTP target equals to payment and anything that is an error in it. So if I look at all these traces, if I open that, again, we're talking about just now, spans are part of a trace. That's the reason why if I expand that, I have the trace ID, I have the span ID. Now, when I open look and like at this span ID, it will bring me to pretty much the detailed view of the flame graph earlier. So I'll just move this guy here, make it easier for us to see. So we have this full trace ID, and this is the span that just now I was talking about, where the error comes in. If I kind of like look at the trace here, this particular span, there's this error indicator assigned to it. That's where the status error comes in. So when I look at all of these things, we have this one request at the top. Let's have an error, and then follow up, there's another call. Within this call, actually, there's another error that kind of originated from this particular call. That is kind of like a Postgres query insert, right? So this is like the span name itself that we see. If you look at the attributes, again, this attribute is something that you insert as you are generating the spans. We can see things like the connection string, the database name, the database statement, the DB system, and so on as well here, right? So if you are putting more context into attributes, there are more things that you can see as you are exploring your traces. Now, another thing that you can do from here is, just earlier we talked about the correlation between the trace metrics and the logs. In one simple view here, if I want to look at the logs for this particular span, I can just do that by clicking on the logs for this span. It will bring me my Loki on the right side. And this has been pre-filtered based on whatever I set up here. So this is the configuration that will be set up at the tempo side as you are kind of like configuring the Grafana itself. And similarly from here, I can also configure, like say, I want to look at the request rate, for example. This will pretty much bring me my Vimeo at the right side where all the request rate information will be presented to me. So these are the correlations that can be configured between all these metrics, logs, and the traces. So for example, for the logs earlier, if I go back to my dashboard here, let's say I start, so just now I start my investigation from here, I click, right? Because I like anything red, I just want to click it. If I go all the way to the bottom, I have this log as well that's embedded inside my dashboard. This log pretty much has been applied with that line format just now I show you with the loggy. So I have this, because your log line will have this fancy emoji as part of it. This is something that I put as part of the dashboard. So this is the line format thing that I set it up. So it's much easier for anyone to look at this. I know, okay, error found for this trace ID, duration is what, and which are the service, right? If I expand one of it, there's something that's called a link. So this link, when I click, this will bring me into my trace view directly. So I just move from a log directly to the trace. So there's one other path that I can take when I'm doing my investigations. The next part from the metrics, Prometheus has something called as exemplar. Thinking of exemplar is, because to me, when I hear about it's a very fancy term. Simply put, is metrics is just numbers as usual. Exemplar essentially add allowing the capability allow you to add a context into your given metrics. So in this case, I have this one point. There's the metrics value. We still see the value here. But also I can add the context, other context. I think, for example, here is a trace ID. Clicking this will pretty much bring me to the same trace ID that we see earlier, right? So there's just a quick look of the tempo itself. I will skip through some of this stuff here because I already showed that to you. So how we can leverage tempo is by doing things like just now the correlations, building the, for you when you are doing a tree judge, you can do the correlation as you see fit, application performance. So this is the trace QL I was talking about earlier. You can pretty much do the trace QL, defining it based on like your attributes, do that. And then if you want to look at specific, anything that has status code more than 200, or you want to look at specific span HTTP URL, you can do that pretty much with the trace QL as well, right? And of course, lastly, the application insight I was talking about earlier with the capability for the metrics generator that we have. Right? There's another thing that metric generator also allow you to do is this node graph, which essentially is a service graph view that you can set up out of your applications. All right, so I covered that in like 15 minutes. Yeah, okay, not bad. All right, so any questions? Apologize, I talk too much as usual.
So the logs related to a trace, is that refer just to trace spans and things?
Yeah, so if
Or-
I look at, correct.
Yeah, or does that, like if you add the trace ID for your general sort of logs, will that bring in extra stuff as well?
Yep.
Okay.
Yep. So for that to work is first you need to have the trace ID as part of your log line. So in these examples, I have that. Just to be fair, this guy is not cheating. I'll just open the log itself. I just remove this line format. Just so that this guy is putting some dummy data in. It is a data generated, but it's still an actual data. So we have this trace ID in the log line, right? So in this log line, if I go, for instance, to my okay, by the way, if you are using a new Grafana 9 onwards, we have Grafana 10 released last week. We have this command palette that I've been using a lot. So if I go to the data source, I go to my loggy configurations. There is something called as a derived fields. Derived fields is what define, allow you to tell Grafana essentially is if you find this pattern, give that data link view the button for you to click, and it will go to the trace data source that I have here, tempo, and put that this query. The query itself is pretty much just the trace ID directly we see here. Like if I click on this is the one. I'm sorry. So I go here. They will have like this one. If I open that, they will just throw in this value into that. Right. So there's like the configuration you can set up at the Loki. Grafana itself support this derived field for other data source as well, not just Loki, namely it's Elasticsearch and Splunk. So if you have your logs there, you pretty much can configure the derived field configurations as you need as well. Cool. Anything else? All right, otherwise then.
Any other questions? Actually, I have one question for like from a Red Hat perspective, right? I mean, because for OpenShift, I think storage is always a consideration when we always do architectural diagrams and we speak to our customers as well. One of the components, as you mentioned, S3, right, is being used for example, Loki, and then potentially, as you mentioned, Tempo. So we always use S3 as well. I think in our documentation, we said that it's about, depends on the size of the Loki stack, then the
Ingested
correct.
logs size.
So we're thinking from usually what's a good sizing for object storage for Loki? Because it mentions that it can ingest how much terabytes per day. Right. So we were just afraid that, you know, it will use up too much.
Yeah. So with regards to the sizing, recently our product team kind of like put up this sizing cluster in our documentations. So it's just like Loki documentations under installations. There's something called size cluster. This is helpful from the perspective of I want to create a Loki cluster, but I want to know how many nodes I need and so on, right? So just here, you just choose like your node type, your ingest size, and your log retention. You can. So this like very much in simplified view. Do you perform a lot of query, or you are a superhuman that query everything every single second? And of course, it's something I make up, not the engineering. Don't come to government engineering say that. This is basically if you are running a simple query or very more complex, heavy query. The result of this, you will have this like value. This value file is basically something that looks like this. This is something that you can be able to use as part of the Helm charts. One thing, this sizing cluster is based on the simple scalable deployment, and this will give you the Helm chart value that you will need as well. Now to the questions, we typically for the storage size, because it's S3, we tend to kind of like, because it tend to be able to just expand as it's required. It's not something like a local disk that you need to kind of like provisions much early on. So typically we do not really think about that like in the early stage, like when you are doing the sizing. But in general, in terms of like compression size, I think the last I checked, it's usually the rough number we take is like around 15%, like your raw log size, and then how much storage you will need. Yeah, so it's kind of like a different conversations from the perspective of like how much storage you need, because it's S3, and then we talk about that, typically it's just auto expand. There's no limit in that sense, right? So we don't really have like you must provision this much hard disk upfront, because you do not need to in a sense. But in general, I think talking about compression rate, the number that typically we are using is around 15% roughly. Loki support multiple compressions format as well. If you look at the Loki configurations, there's a few compressions format that we can support, like gzips included as one, and there's a few other things included as well, if I'm mistaken. So yeah.
Any other questions?
So that means if your logs total, let's say 100 gig, right? So if we go to the Loki to the S3, probably we are looking at 20 gig.
Yeah, yeah. Just thinking more. Yeah, something around that. That would be kind of like rough number estimations. Again, the good things while we also think about pretty much our metrics log and the tracers use object storage. It kind of like help from the perspective of like doing the implementations or like designing in much earlier stage. You do not need to think so much about how much hard disk I need to provisions. Because some tools, like in my previous job, I need to think about, all right, what is your log size? What is your retentions? What is your replications? And then All right, based on that, I calculate, put some my math in. Okay, you will need this much of storage, and you need to provision this much of SSD from your server thinking, for example, right? But with S3, because of the nature of the S3 itself, the object storage, it's much more. It can be put kind of like, I wouldn't say like afterthought, but it's kind of like lower priority when we are kind of like thinking of the storage, because it's kind of like auto scale in a sense. It's auto expand. I think that's better.
Any other questions? Yep.
So Loki stores only logs or does it even store metrics?
It only store the logs. So the metrics that just now I showed you when you are running the query and you're able to pull up the metrics value, it's technically not getting stored anywhere. So it's a result of a query. A result of a query. So when we talk about you're able to use logql to get a metrics, essentially the logql itself process the logs and then generate the metrics presentable to you.
So Prometheus still remains in my OpenShift cluster, right?
Yes.
It's not going to be replaced.
No. No. Yes. No. So Grafana and Prometheus is really there. We have Loki, adding Loki to the whole stack itself, and then Tempo is for us is tech preview. Yeah.
So from 4.13 version onwards, you are
Yes.
recommending to install Loki instead of Elasticsearch?
The recommended default would be Loki. Yeah.
The default is still Elastic.
Mhm.
This is an alternative that we are
Okay.
introducing as a new one. So moving forward, depends on your use case and stuff like that.
So
we have 12.
Logging namespace for EFK. So in the same namespace, this Loki also are coming up with
You
different.
choose either one.
Yeah.
You don't need two logging. Yeah, so if you are using
Different one.
Elastic, then continue to use Elastic. You just can do your own space. But the good thing about Loki, it support multi-tenancy as well. Which
Okay, so we need to install that operator.
yes,
Instead of logging operator, we have to install.
yes, it's called Loki stack.
And it's a hard requirement to have an object storage, is it?
For OpenShift,
Oh, Loki.
for Loki, yeah, we store our data in objects.
Only object storage.
We support file system as well, but we don't recommend that for productions or anything outside of installing it on your desktop, for example. Yeah, or your PC or your workstation. Sorry.
This whatever tempo,
Yeah.
it's not. Okay, all the namespaces are still will be for only service discount. Makes sense.
So for
And that is so much. So we do not process. Just all.
Why I ask that question is because some of our customers that we speak to, usually will ask for sizing for object storage.
Yeah.
And sometimes they don't have cloud access where they can put S3 bucket there.
Yep.
Usually it's probably from like maybe Nimbra or
Yeah.
some other sources as on-premise.
Yeah, okay, makes sense. Yeah, so for this kind of like, because we also have like an on-prem deployment, for this kind of situations, then typically we internally will do calculations to help them. So with the help with the engineering team based on this much of data per day, the query, how much storage you will need, the CPU and those kind of things as well. The earlier the public one, it's kind of like one steps that we are taking to help a wider audience, a community as well, if they want to deploy, how much data and how much infrastructure they will need. But in that sense, I think one thing that I probably can check with the product manager is on like, are they planning to kind of like insert an estimate of a storage size thing? I think listening to you guys, it makes more sense for those non-cloud deployment. It's something that you need to think about, like the object storage itself, how much it would go. Yeah, I'll probably check with that. See whether there's any plan. I think it should be. It's just like not sure the timeline when they're gonna push that.
One last question.
Yeah.
So right now, till 4.12, we are using EFK.
Yeah.
4.13, if I want to move to Loki, so can I migrate from EFK to Loki with existing data, whatever I have right now?
Good question.
you also support migration.
Yeah, you have to. You simply say, I have the option, go Loki.
Yeah.
What- what I have to I have to migrate, right, existing
Yes,
data,
I
otherwise it's
understand.
like empty.
So I think you can, for this kind of use case, you can run parallel EFK, but archive new logs are sent over to Loki. So you can still,
Additional resources I have to spend on looking.
maybe there will be this interim period, because I think the logs are stored in two different backend systems, right? Elastic and Loki stored in different combinations. So I don't know whether there's migration. That's not something here to say, but yeah, I think there should be an interim period where you need to do that transition.
I mean, putting off my Grafana hat just like as a normal IT guy, the migrations period there, it's possible that you are running concurrent. So let your old logs age out in your older tools, while in parallel anything new will be going through that new stack, right? And you just run the search from there. The old, it hit the retention period of the older one, it disappeared and you can decommission that as well. Yeah, I think for OpenShift, you guys give me like 7 days or something.
We are going towards 30 days
Okay, yeah. So that's
for Loki.
one possibility. Now I'm wearing my Grafana hat again. So if you kind of like use like the EFK in that sense, and then you have Loki, there will be a period that you need to search through different storage system, right? Grafana pretty much solved that because you have a plugin that allows you to search data from Elastic and allow you to search data from Loki as well. You can even build a panel that queries both data and present it in one panel. So from a user perspective, when they're opening a dashboards, just see all the log line sorted by the time range. Yeah. But again, I'm kind of like putting a Grafana into the whole solution. So I need to wear that.
Okay, for outside, probably we need to check back also for the migration strategy.
Because for the migration, you're talking about Elasticsearch to Loki, right?
Ah,
So I think you just got to remember that the default Elasticsearch in OpenShift supports up to only 7 to 14 days. So the one of the strategies is actually to have both at the same time, while you wait for the retention date of Elasticsearch to expire before you fully migrate to Loki. Yeah. So that's one way you can do it as well. So you deploy Elasticsearch and then you deploy Loki. You switch the log forwarding to Loki, wait for the 7 days to run out, then that's when you switch your Kibana over as well. That's another way to do it.
any other questions? Okay, I guess, thank you, Yuri, for your time. Yeah.